Okay, alright. Um, Hello, I think I'm live. Let's see. Alright, yep. Computer crashed. I had to reboot it, like, as soon as I started streaming. I mean, my streaming computer's fine. Uh, Computers, what can you do? You could build better computers. Alright. Um, okay, so, um, while Casey was streaming yesterday, last night, or whatever, depending on what time zone you were in, um, I went ahead and finished up a couple features, or finished up changing around the stuff I was talking about at the end of the last stream. So maybe just to catch everybody up real quick, I was sort of moving around the watch window stuff, and I was moving some of the logic and the retained state from the GUI side of things into the core side of the program. So basically, what that means is that I have a little bit more control over um, being able to add um, like multiple watches with the same name and thread ID and all that stuff. So it basically makes the idea of the creation of the watch more explicit. Um, Whereas like the old way worked, where the GUI side basically just looked at the core side and said, hey, I need a watch with these parameters, and it said, oh, okay, well, if I don't have one, I'll make one. And now it's like, oh, well, I'm going to explicitly tell you to make one. So I feel like this is like a little bit. I feel like this is better for a GUI application, but I'm a little bit concerned about how it might that it might cause extra steps for someone who's just trying to implement like a tool, or something that just basically needs to read off of one little thing at a time. Like, so like right now reading like this test struct value is like you have to create this object and then it passes you back like a pointer, and you have to go get the pointer, and then like you'll have to like delete the object if you don't want it to like exist, sit around forever. So anyway, um, so I don't know. Like the old system, I think was a little bit nicer. I'm gonna go ahead and let's see, refresh, um, rescan. Okay. There we go. And so let's just test it out and see where we're at on this. So, oh, well, I mean, we segfault. So that's where we're at. Assertion, func name. So I just added that in. That's one of the recent things that I had added in. Let's see what the issue is. I was basically saying that. Oh, yeah, this doesn't make sense. else. So what happens when you try to program while watching other people stream? Okay, there we go. Okay, so we start, and let's go ahead and add a watch for this window that for this frame that we're in. If I do test tab, it completes out to these options here, and everything works so far with that. Okay, so let's say I set a breakpoint in like other nested here, and then a multiple nested 2. Okay, so let's continue. We're in nested other nested right now. Okay, so let's look at test struct and see what our options are. So we already have one in main right now, so let's do test struct. And just so you know, like, what's going on is that I've got multiple variables with the same name in each frame, and I'm just sort of testing my ability to see all of those, be able to distinguish those variables. And that was something that we were kind of struggling with before. So, oh, thanks for the follow, Jay Granahan. I hope that I said that properly. Feel free to correct me if I'm wrong. Okay, so I hit test struct, and it completes out to 3 different options that I can choose from. And let's go ahead and just do all of them, even the one I already have. So I should have 4 entries now, and one of them will be a duplicate. So let's go to frame 0 and other nested. Okay, and this properly registering the type, test struct 4, public, and all of its members. It says mostly the same members, but it has bool 4, which is nice that it picked that up. So I expected that before. I was just kind of wondering. It's kind of just confirming that everything's working fine, especially since I just overhauled all this code. Okay, so let's see, test struct, multiple test. Okay, that one's test struct 2. Let's write here. Okay. And it's getting its stuff. Good deal. That should. Okay. We should probably figure out a way to get rid of this public member. I don't know. Maybe like a way to just sort of like compress down things that just have one child. I'm going to add that to the to-do real quick. So pardon me, off screen. I'm going to log into Trello here and mark that as a to-do. Watch window, compress, elements with one child into parent to compress to how do I want to say, visually, for more condensed layout. Okay. I don't know. I feel like it's enough detail that I'll at least have a good idea of what I meant last time. Next time I look at that tree. Okay, so here we go. We got all those. I was going to add another one for the one in Maine. Oh, here's an issue. It went ahead and removed that one that was an error. You know what? I don't think we actually want that functionality. So I'm going to go here and say, yeah, it doesn't make sense to try to add something and it just disappears right away. We should at least report an error, right? So, let's do, yeah, that's actually something we should probably look at here. Because like, even if I did leave it in there, there's like, some error information that makes it to the console that doesn't make it to the watch window even before. So let's go to watch add here, and I have this logic in here that's like, if it is an error and it's not floating, then delete it. So I'm just gonna say like and false here for now. So that code path will permanently be disabled. So let's go ahead and run. Okay, so let's do test blah blah blah, right? Okay, so there we go. Now it didn't remove it, so there's an error, right? Okay. Okay, so let's look at this thing here. So I'm not sure. Actually, I think this is an appropriate amount of error information because obviously this doesn't exist, and I don't think that the console actually provides any meaningful additional information. So let's so I'm not really concerned about trying to pull over more information into the watch window. I mean, that may change. I think there were some. I think the reason I was thinking with that is because sometimes there is actual information, but I think I need to see an example of that before we try to press the issue on that. So we've got an error there. That's good. Let's go ahead and remove that. And then let's do. So let's do one more from main from this frame. So it should be the same as this, except the frame number will be different. So I'm actually thinking about taking out the frame number, just because it's kind of confusing. But it might be the only way to distinguish. There it is, test struct in main. It might be the only way to distinguish two functions that call, or a single function that calls itself. Multiple frames there. And I think what I want to do then is maybe like display the address of the variable. And that might be the thing to do. I don't know. But I kind of decided that's probably maybe like something I could try to get done in a second pass, maybe, because I'm kind of tired of working on the watch window at this point, because I feel like I've been working on the watch window for like a month, a month's worth of weekends. Um, when I really expected it to be done in like one weekend. So I don't know. We'll see. Um, so I mean, it's not like that would be very difficult to add, for sure. Um, so, um, so we've got this, right? So we plus into it, and it's got the proper type. Okay, that's great. Okay, so let's add a floating variable as well. So right now we're switched to uh, pinned, so we want to toggle it to floating, and then we'll do test struct. Right? Oh, and we get a seg fault. Okay, so glad we tested that. There's so much shit in that line. Uh, hmm. So thread is null. Interesting. Excuse me. So I think what we want to do here is we want to do if thread. Right? And then we should be good. Yeah. Actually, I think what we want to do is if thread ID. Right. Man, I must have been really tired. Okay. So we've got all that. That did not compile fine. What do we got here? Okay. We're gonna run. Okay. Good. Load, start. Test struct. Okay. Let's go ahead and add our floating value now. So test struct. Okay, so there it is. It's floating. Good. Now. So let's get our breakpoints here. So what, nested 2 and other nested. Okay, good deal. Let's go to continue, test struct 4. Okay, so that is a problem that we still need to address, is that when the type changes, it does not like try to re-get its child names. So so I think we need to look at that here. Oh, it's not what we want. We want this. Okay. So what do we have here? type change true. Number of children. Okay, so HB. So it's just doing var update. Okay. For HB2, which is test struct 4. Yes. Okay. Type changed. Okay, and so like this stuff, I think, is just unrelated. Yeah. So I think what we want to do is say that like if we get a new type or new num children, then we need to go ahead and do var list children again. Okay, so trying to figure out the best way to handle that. So, okay, let's look at the spec file that the parsing code is in. All right, let's look for new num children. There it is. Okay, so so we could easily do like here a literal if new num children or new type, right? You know, I think what we want to do is like set some sort of flag, like WE needs child rescan, needs reset, or something. Needs child reset equals true. I don't know. Okay, and then what we need to do is say right here, humbug var update, right? Parse var update, good. So I know I fully understand that like this is a, you know, probably not like the best thing to do, but sort of like through this pass we're just kind of like doing the dumb thing or the easiest thing that we can code out first, just get some functionality. So let's see here. So basically I wanted to do a list. I mean, I could do yeah. Also, I just realized here we want to do like thread ID, or because we never really want to retry things that weren't pinned to a thread. And then here we want to do like if that needs reset, needs child reset. Then what are we going to do here? I think what we want to do is watch set child range I 0, 0, right? I think that's what we want. Needs child reset. We need to add that as a thing. Watched expression. There we go. Full needs child reset. Oh, and we also need to set it to false, or else we'll like, yeah. Right. So there we go. That's that. No compiler is great. Let's try again. Let's switch this to a tail. Let's switch it to a tail follow. Even. And let's see. What do we got? So let's go ahead and reset that, right? So let's add the entry again, test struct floating. Okay, so it properly gets the right amount of children. Okay. And so if we do, so bool 4, that's correct, for test struct 4. And then we do a, let's do a finish. So we're going to step out of that frame right now. So test struct 2. So test struct 4, change to test struct 2, which is what we would expect. And it also collapsed it back in, which is what we would expect. However, I do not expect the segmentation fault to happen. Why? So HB item is a null. Okay. So we got null back from watch get child. It's I. I is 4. Okay. Okay, so it's test struct 2. Let's look at the code here. So 4 is the proper number of elements. So that is correct. So let's look at what getChild is doing. Okay. So actually, also I want to know what PHB item child count looks like. Okay, so that is correct. How are we getting to 4? HB item, child range, and 5. Okay. So that should be 4, but it's 5. So we're not getting the right child range here. And let's see here. I think that makes sense. Right. Okay. So let's look at how varless children is working. Actually, I think I need to do. It's in like the parsing code, right? So parse var update, and here is the parse var create, parse var list children. Okay. So here we go. Okay, so here's this thing. Okay, so what we need to do really is so I don't think we're properly recursively taking care of the children. Like when we free. Right? Yeah. So I wonder if this is actually getting hit. So I want to set a, I want to reset the state here. So load, start, test struct. Actually, continue. So we're there. And it's a test struct here. And, right, we have children. Okay. And then I want to set a breakpoint in HUMBUG watch set child range. Okay, continue. And well, I think I could do it just by hitting minus. Let's see what that does. Alright, so there we go. That's where we're hit. It's set to 0, 0. So let's do next. Okay, so it is a root element. Nice, okay. Okay, so right now, P watch. Let's go ahead and just print all the elements there, or the members there. Watch range start 0, range end 1. Okay, so it should be from that. It should be changing from 1 to 0. You know, there, child range end. So we should see it hit at least one condition. So, so I think it should be hitting at least one time in this loop, right? So let's see here. Next. No, it didn't. Interesting. Okay, so I think I have a bug there. Let's see here. Okay, so it's going through. It's going to start at the end of wherever it is now, or it's the new end. So if the new end is less than the previous end, then it should go through each one there and count up. Okay, so oh, I think this is just an off by 1. Right? This is just, should be that, I think. I don't know. I'm terrible with off by 1 issues. Load, start. Other nested. Nested 2. Okay. Continue. So we're in other nested. We'll do test struct. Struct. There we go. We'll expand it out. Oh, and we hit a breakpoint. We'll continue. Okay. And then we'll expand out again. And we'll continue. I'm just going to clear this breakpoint for now. Okay. There, everything works. Everything's peachy. And then we're going to finish out of the function. So it's stale. All right, okay, because it's not floating. Okay. So let's go ahead and add a floating entry here. Well, actually, let's remove that, restart, continue, toggle the floating, test struct. There. Okay. Test struct for. Is that the proper number of members here? So we should have a bool 4 that we don't have. Yeah, okay. So it's definitely not updating. Interesting. Okay. Okay, so numchild 5. Why is that? Yeah, okay, so something's not quite right. Let's go ahead and set our breakpoint again. There. So set children there. Let's go ahead. So we're at test struct 4, which means we really should have 5 child elements in public, right? 1, 2, 3, 4, 5. Yep. So P watch. So test struct 4. Okay. So it's setting the start and end to 0, 0, which means that it should free all of its children. Okay, so and let's also look at child count is 1. Okay, so that's fine because it's got that public list entry there. Okay, so next. Why are we calling varless children? Oh, right. Next. You know, we could do a slight optimization here. And that was be if, like, to do only run varless children if new range has items old range didn't. Okay, so let's go ahead and add that here and there. Okay. Okay, but it doesn't matter if we call it unnecessarily, because it wouldn't do anything, because it wouldn't get any results that we don't already have. Well, I mean, in this case, it wouldn't get any results, because it's going from a range of 0 to 0. So, where are we at here? 708. Next. Why is it? I don't know. Alright, so we are like as your P watch child range start. And our new end is 0. So we should be hitting 724. Next, yeah, and we do step. Oh, right. The line numbers don't match up because I edited the file. What's going on? All right, whatever. I was hoping it would step. Okay, all right. Let's not edit the file this time, so it's debuggable. That's something I need to fix in my debugger. Okay, what other nested? Here, continue, test struct. Okay. Okay, and we'll continue here, and we'll continue here. Bull 4, that's great. Okay. And so we're gonna go ahead and switch to this frame. Which, oh, it's not a floating value. Damn it. Alright, so let's go ahead and remove this. And we're going to toggle this to floating, and we're going to do test struct. Right. Expansion is continue. Expand this. Continue. Alright. Then we're going to switch to frame. The main, so that one. Hold on, did that just work? Okay, no it didn't. Okay. So that, okay. So it definitely compacted it fine. But it's not expanding it right. Okay, so what's going on here? Okay. So, next. Next. Oh, I know what's going on. This is, okay, continue. Yeah, okay, so it is working right. It's just, it's not resetting that that member for some reason. Okay, so what's the deal with that? Um, so, hmm. I think this might be the problem here. Well, no, that's not the problem. Why isn't it? Okay, so it's like it's not removing the children. So, let's figure this out. So, let's clear this breakpoint and continue. Um, okay, so when we compress this, or we like close this, it should get rid of that object. Like all those structures should be freed. Why does it remember that it's expanded? Or yeah. So I think that's the root of the problem here. Um, so if we go to let's do a breakpoint in free in watch free. So be humbug watch free. So press that. So it never calls those. It never calls them. That's not right. Okay, so that's probably the bug here. So let's do break in humbug. Watch. Set child range. Continue. Okay, and then do a right here. Okay, so our new range is 0, 0. It's good. So next. Next. Start. So, let's do watch. So the current child range is 1. Okay, so if we hit next here, and we hit next again, so it doesn't hit that. All right, so I'm like gonna have to like think this like through, because this is not doing what we want. Oh, damn it. Oh, okay. Well, anyway, we want and I think we want it to actually start at that value. Okay, so if I is less than range so if it was 5 and now the end is 4, so it'll start at 4 go to 5. So that's what we want, except for the fact that the end, it's like an off by 1 thing. So No, we really always wanted this to be -1 here. Right. So like, let's just go through some examples here. So if we were at 5, well, if we were at 5, but now we're ending at 4. Let's go through the. So right now the issue is that it was at 1, now it's going to 0. So if it's at 1, then end would be 0. So I equals 0. And if 0 is less than 1, that should run. Why isn't that working? It totally should work. Let's step through it. P and P watch child range and is 1. Okay. So -1. Am I like an idiot or something? I feel like this is a very simple problem. Why am I having such a tough time reasoning through it? Maybe it's the caffeine. I haven't had enough caffeine yet. Okay, so now we want this to be. So we want to start at the end. That'll be the first element which we free. And then yes, okay. So that's right. That's what we want. Okay, so let's run that, see if it does what we want. Start. Let's go here and toggle floating test struct. Okay. And so we hit the breakpoint. Let's clear. Continue. So we expand out. That's fine. It's the proper number of items here. And then we will run to other nested here. Continue. And okay, so we hit watch free. I don't think we hit that before, so that's good. Clear. Continue. Okay. Okay. And so it's the proper number of elements. So if we switch to mainframe, and okay, so that works. I'm wondering now if we should do something to remember the expansion of these things here. I'm not sure how we would handle that. We would need some sort of like cache object or like some sort of map. I don't know. Hash map, maybe. But whatever. Because we can't, the way that we're doing it now, we can't conveniently store it, on the structure. So, but anyway, so that's working now. That's good. So, Okay. So let's search for test structs here. And we've got this one, that one, and that one. And so those all exist there. It's fine. And they are all the proper things here. Alright, so that's that. Okay, so that's working. And so now if we finish out of that function, we go to here, that became stale, and this one became test struct 2. Interesting. Okay, let's make it big. And so, and if we finish out of that function, so is that other number 59 or 56? Okay, so if we finish out of that function, then okay, good deal. That's good. And then let's go ahead and go to